Hi, it's me again, Miss Sullivan, and I want to talk to you about the last index law for the moment, which is raising a number. Well, really, it's the last index law. It's all about raising a number to the power of a negative n. So basically, we're working with negative indices. I'm just going to say the little rhyme now, and you'll see why it makes sense later. You change the sign, you cross the line. So essentially, I'm about to draw a table and I want you to copy it. And that table is going to show you why a to the power of negative n. A to the power of negative n equals 1 over a to the power of n. Or 1 divided by a to the power of n. All right, I'm going to draw this table. So, it's probably the easiest way to explain it. So I'm going to let's do some things that we already know about. I'm going to say that I've got n, and I'm going to go 3, 2, 1, 0. That's n. I'll draw a little line down here, and I'm going to want another 1, 2, 3 at least. And then I'm going to have my base. And this time my base is going to be 2. 2, 2, 2, 2. And I'm going to keep this going so you can see that a pattern is coming. And now I'm going to calculate that. So let's have a look. 2 to the power of 3. 2 to the power of 3. Okay, I know that that equals 1, 2, 3. 2 times 2 is 4 times 2 equals 8. Let's have a look at this next one. 2 to the power of 2. So I know that that's just 2 times 2. And I know that that equals 4. We've talked about this before. 2 to the power of 1. I am not multiplying 2 by itself. I've just got 2. 2 to the power of 0, well, we know anything to the power of 0, anything except 0 to the power of 0 equals 1. All right, so let's have a little look here, because there's definitely a pattern. So we'll go this way. 1 by moving up this way times 2 is 2. 2 times 2 is 4. And 4 times 2 is 8. So if I'm moving up this way, times 2 times 2 times 2. All right. So let's have a little bit of a think about what happens if I want to move in a downward direction. Raising a power, we've got to remember, we're always talking multiplication. So 8 multiplied by what's going to bring me to 4? 8 multiplied by a half brings me to 4. 4 multiplied by a half brings me to 2. 2 multiplied by a half brings me to 1. Right, so what happens when I go 1 multiplied by a half? Okay, 1 multiplied by a half. All right, we're moving in the downward direction. 1 multiplied by a half becomes, well, let's fill this in. 1 multiplied by a half becomes 1 divided by 2. 2 multiplied by a half is basically, well, we'll have a look in a second. So to get to this half, fill this in, heading down. So 2 to the power of negative 1 equals 1 over 2. That's what my rule said. 2 to the power of negative 2 equals 1 over 2 times 2, which equals 1 over 4. Yep, that times a half is 4. Let's have a look at it one more time. 2 to the power of negative 3 is 1 over 1 divided by 2 times 2 times 2, which is 2 times 2 is 4 times 2 is 8. 1 over 8, 2 times a half. Yep, that's definitely an eighth. So having a look at the table, we can conclude that it is in fact true. When we're working with negative indices, you change the sign. So let's have a look up here. You change from working with positives and a 0 to negatives. You change the sign, you cross the line. Excellent. So I really hope you've copied that table into your book so that you can understand why a to the power of negative n is actually at 1 divided a to the power of n. Terrific. So let's have one last run through of those rules. Multiplication, shortcut, same base, check, check. A to the power of m times a to the power of n equals a, m plus n. Great. Division. A, same bases, a to the power of m divided by a to the power of n. The shortcut is a, m minus n to the power of m minus n. Using that, we were able to ascertain that anything, a could be anything except 0. Anything to the power of 0 is going to equal 1. Beautiful. Essentially, you're timesing something by 1 or dividing something by 1. You just have, when we had to the power of 1, you just had itself. To the power of 0, the answer is 1. So when we get to the power of another power, we've got to remember everything inside the bracket needs to be raised to the power outside the brackets because it's a, m times n. A to the power of m multiplied by n. Whatever's going on in here, we're going to raise it to the power of n. And then finally, working with negative indices. When you're working with a negative n, a to the power of negative n, you change the sign, you cross the line. It's 1 over a to the power of n. Note that was not negative n, it's a to the power of positive n as the denominator. Excellent.